girls, welcome back. Last class we looked at land and sea breezes and we looked at the methods of heat transfer. We also began looking at some of the applications of heat transfer. Today what we'll be looking at is the working and the features of the vacuum flask that makes it suitable for keeping hot liquids hot or cold liquids cold. Next we'll be looking at the solar water heater and some of the special features that it has to help maximize heating water. So let's look at the first one, which is the vacuum flask. So this can be found on page 111 of Collins' Concise Revision Course for CSEC Integrated Science. So the first feature that we will be looking at is going to be the insulating cover. The vacuum flask is sealed off completely with an insulated cover. It would reduce conduction because of the insulation, so heat from the outside, which heats up the container here, would not penetrate into the flask itself. And similarly, any liquid that is touching the cover here would not heat it up and cause heat to be released or escape through conduction. It also prevents hot air from leaving by convection, because if I have a liquid or some substance inside here, we are going to have this hot liquid inside here heating up the air just above the surface of it. That now can escape if the cover is opened. So if this was an open top like a cup or like a glass, then you'll constantly have heat being escaped through the opening. So the insulating cover reduces heat loss in those two ways. The next feature is the polished silver exterior. Typically, for the best results, a thermos, as we know it as, or a vacuum flask should have a polished, shiny exterior, right? If it's shiny, it is going to bounce off any or reflect any heat or any radiation coming towards it, right? So the polished silver surface is going to reduce emissions, and it's also going to reduce absorptions of radiation. Next is a vacuum, hence why it's called a vacuum flask, because it is a flask that contains a vacuum. So it's also called sometimes a double-walled vessel because we have two walls. So this is an insulated area here. This blue region is an insulated area. We will look at that next. But this region here is a vacuum, right? Remember, a vacuum has no particles, right? There are no particles, so that way it reduces any transfer by conduction or convection, because those two methods of heat transfer cannot occur in a vacuum. So that automatically minimizes your heat loss to only being radiation, right? The walls are also silver to help reduce radiation. Then we have an insulating case. So this insulation will prevent heat being lost or gained through this surface, as well as anything that may have passed through radiation to reach it. Right? So most of the time it helps you with reducing conduction from the outer walls as well as from your substance on the inner walls. The last feature is insulating shock pads. These insulating shock pads, they also help to reduce conduction. Right? So the main feature of a vacuum flask, which helps to keep hot things hot and cold things cold, is the vacuum layer. So it's very, very efficient. Next, let us look at the solar water heater. So the solar water heater, it has many features that make the heating of this water very sustainable. So the first thing you will have is cool water coming from your mains. So it's going to be entering. The cool water is going to be entering right here, and it's entered at the bottom of your storage tank, right? Why it's so? Because when the hot water comes back in, it will be filled to the top right? And hot liquids tend to be weighing less, meaning that they are less dense, so they are going to basically be above the cold water. The cool water will sink to the bottom while the hot water will be on top. So we then have this cool water flowing down here into our heating panel. When you reach the heating panel, there are several features here. So in the heating panel, there are small copper tubes, right? So what the copper tubes done is that they will cause the walls of that copper tubing to heat up so that it can heat up the water very easily via conduction. The copper surface it's also made out of metal. So copper is a metal, so that the heat energy and the rays from the sun will heat up that metal and also aid in heating the water, because remember, water is a poor conductor of heat, so you need to maximize all different ways to get that water heated. Because the copper panels also are thin, then it will cause a larger surface area being exposed to the water, so it will help heat it up. Another feature is the black surface, right? So the copper surface is typically painted black so that it will maximize absorption of heat, right? So it will maximize the absorption of the solar radiation, and then via conduction the water will be heated. The hot water, it then transfers into the storage tank. Right, so the hot water then travels up these pipes and into the storage tank through the top, right? And that is because it will help to maintain the temperature as much as possible, because it's gonna float above basically the cooler water, because it is going to be less dense. Now this storage tank also has some features. It is silver to reduce radiation being emitted. It is also insulated, so this gray region is an insulated region all the way around the storage tank, so that will prevent loss of heat via conduction from the tank to the atmosphere, right? And also the hot water tap is connected through the top so that you can get hot water. Right, as the water is cooling inside here, obviously it's going to sink back down to the bottom and the whole process is going to start again. Right, so those are some of the features of the solar water heater and the vacuum flask to minimize heat losses. Well, in the case of the vacuum flask, you want to minimize heat losses to the environment via conduction, convection, and radiation. The solar water heater, we want to maximize heat absorption in this region here, and we want to maximize heat loss over here. Right, so you don't want heat being lost from the storage tank, and you want heat to enter your heater panel. So the features are very different in both sections of the solar water heater. In our next class, we will begin looking at thermostatic control. So we'll be looking at thermostats, bimetallic strips, and then go on to temperature and thermometers. So you can start reading up as we prepare for our next class.